That's some techniques of differentiation. Okay, and in the previous video, we've already established the uh, general formula for differentiation. Okay, we said in the previous video that if y is a xn, okay, where your a is constant, your the y dx, which you call the differential coefficient or derivative, will be equal to this n will go to the front, and that will be n times the constant here, and that will be a n, and then write this one, then minus 1. So you see that that is that on that. Okay, and if your function is y equal to x to power n, so the differential coefficient will equal to what? This power will come to the front, and you have this case. This is when there is no constant here. You have that. If you are differentiating at constants, y equal to c, there is no attachment of x there. Okay, the derivative of a constant, the differential coefficient of a constant is 0. For example, now you have y equal to 3. The differential coefficient is what? Of that is what? Is 0. Because we are doing respect to x. So there is no x here. And that's 0. So if you have y equal to 4, and you are doing respect to theta. Okay, there's no theta here. So you make it to a constant, and that will equal to what? That will equal to 0. So that's that on that case. Okay, let's look at the differentiation. Let's look at differentiation of sum or difference of functions. Let's look at that. What happened in that case? Assuming we have y equal to u plus or minus v, where u is a function of x and v is also a function of x. And then the meaning of this plus or minus is that the function could be addition, the function could be what? Subtraction. Okay? So in that case now, your dy dx, which is known as the derivative or differential coefficient, will be equal to the u dx plus or minus the v dx, depending on what you have here. If it's plus, it will be plus. If it's minus, it will be minus. So each of those functions will be respect to x. So that's that on that case. Let's take example on that. Example. Find the differential coefficients. Differential coefficients of if we have x to power 6 minus 7 to power 8 minus 6x plus 4. I want to find the differential coefficients of that. So this is very simple. It's going to be d dx, because it's a function of x, d dx of the function which means we are differentiating each one respect to x, 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 and that will be equal to what? If you do this one based on this rule here, the power will come to the front, write the question again, and subtract 1. Okay, then minus this one. You can go for this one here. The constant, the a here is 7, so it will be 7. The power here is coming to the front there. That's times 8. Okay, and then sorry for using this so not to cause confusion. Probably we can use brackets. Let's use brackets 7, bracket 8, and then write your question x8 minus 1, then minus So that will be then minus differential coefficient of this one has 1 on top, okay, but it's not stated there. We believe all numbers carry has a power of 1. Any number has automatically has a power of 1 is that number, okay. So that will be equal to 6 times 1 and then 1 minus 1 for this place, and then plus. The differential coefficient of a constant is 0. So we don't even need to mention that. And this will give us 6x5, and this will give us 7 times 8. I think that's 56, x7. And this one will give us 1 minus 1 is 0. 0 to the power 0 is 1. Anything to the exponent, anything to the power 0 is 1. Okay, and that will be equal to what? Minus 6 here. Okay, so that's the answer. In a nutshell, whenever you are differentiating 6x, okay, that doesn't have power, okay, maybe just 6x, the derivative is 6, 5x, the derivative is 5, and so on and so forth. So that's that on this question. That's that on this question. So let's see another question. Next question, question 2, example 2. Find derivative. Find derivative of cos x minus sin x. That's that on that question. Find the derivative of this. This is very simple. It's very simple. The derivative of this is going to be d dx of that expression, okay, which will be derivative of each of those functions, okay, with respect to x. So derivative of sin x, in the previous video we've already established, we've explained that, okay, we prove it that sin x is what? Minus, cos x. Derivative of cos x is minus sin x. That's, we have proved it. If you have not watched the video on to see how we did it, okay, please go to that video and watch it. And the derivative of sin x is what? Is cos x. Okay, so this will be equal to minus sin x. The derivative of cos is what? The derivative of sine is cos. The derivative of cos is minus sin x. Just one line. We finish that. Okay. Then the next thing we want to do now, we want to go to the product rule. Differentiation of a product. Differentiation of a product. Let me say product rule. Product rule, or differentiation of a product. Differentiation of a product. Okay, when do we use product rule? Product rule is applicable when you have two items multiplied together. Okay, then product rule will be applicable. What we are saying is this: if y is equal to uv, this is u times v, whereby your u is a function of x and your v is a function of x. Okay, product rule is saying that your differential coefficient will be equal to, you take one item constant, you differentiate the second item. Okay, and the one you have differentiated here, you keep it constant here. The one you have kept constant, in the first instance, you now go for it, u dx. That's just on product rule. It's applicable for when you want to differentiate two items, okay, and they have the same function. That's that on product rule. You keep one constant, you differentiate another one, and then plus the one you are differentiating here, you keep it constant. The one you kept constant here, you differentiate that. That's that on product rule. Let's see questions on product rule. Before we see question, what of if y, one of the item you are multiplying, one of them is constant. Okay, this where C is constant. C is constant. Okay, C is constant and V is what? V is a function of x. So in that case, now what do you do? Your differential coefficient is equal to, you take your C outside, and that will be equal to what? The V and the x. Okay, so that's that on that case. Then the next thing what you do also, if y is equal to AU plus BV and then plus dash 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 WCW. This is where you have cases like this where your A, B, and C are constants. Okay, they are all constants. Your differential coefficient will be equal to the y dx. Okay, this A it will be outside, then that will be the u dx. And don't forget, this u is a function of x. B also is a function of x. Then plus b, this b will be outside, that will be the v dx. Then we waited some values here, okay, and then finally c is a constant, the w dx. Okay, so that's that on that case. Okay, then we want to see, we've explained when you are multiplying two items, it's also possible to have three items be multiplied together. You have your u times v times w, and each of those functions, each of those items, each of them, okay, each of them are functions of x. V also is a function of x. W also is a function of x. Product rule is highly applicable. It could be four items be multiplied together. Product rule is applicable. Let's see how we can use that product rule when you have three items. Okay, this will be equal to y. Okay, y. I'm going to take the first two. I'm going to take it constant, uv as a constant. I'm differentiating the third one, the v dx. Okay, then plus the one you differentiated here, you now keep it constant, and then you now differentiate the one you kept constant at the first instance, and that will be u v. Okay, then we can go on, and this will be uv, the w dx, then plus w. Can we get the product of these two items, which will be equal to, keep u constant, differentiate your v, okay, then plus your v here, which you have differentiated here, take it outside, keep it constant, go for this one, differentiate your u, that's the u dx. Okay, then do the expansion. This will be equal to uv dw, dw dx, then plus u times w, that's u w v dx, plus w times v, w du dx. If you observe now, you see that each of them, you have what? Differentiated them. We have differentiated w, we have differentiated v, we have also differentiated what? U. Okay, and I believe also each of them, two items, have been kept constant. So it's very simple. You just have to follow the principle. The first thing is that take two items constant, differentiate the third one, then plus the one you are differentiating here, take it constant and differentiate the first one which you have kept constant, which is here, and apply product rule for this. Okay, and once you do that, then multiply, open the bracket, and then you get that. Okay, mathematics, we are talking and we don't see a problem, we're just wasting our time. We need to look for problems, we need to look for questions. I mean questions so that we can apply all this. Then you now enjoy the topic, what we are saying. Let's see questions. First one, we want to find the differential coefficient, which is what? ddx of 6 sine x. Okay, and we check the what we said in the example in this video. We said the 6 will go outside. That will be 6 ddx of sine x. Okay, then this will now become derivative of sine is cos. That will be 6 times cos x. That one is done. Very simple. Then case 2. We have ddx of derivative differential coefficient is ddx cos x plus 3 sine x. So in this case now you have sum of functions there. So this is applicable. So differential coefficient will goes into this, and that will be ddx of cos x, then plus the 3 will come outside, ddx of sine x, and this will give us differential coefficient as we've done the proving, and that is how we've shown this the previous video, that this is what minus sine x plus differential coefficient of cos is 3, 3 and of sine is cos, and that will be 3 cos x, cos times 3. So that's that on that aspect. Then the next question I want to look into is going to be on this third part. Okay, yeah, the third question. We have 6x squared sine x cos x. So as we have I've said that we're going to use this is a product of 3 items u, v, w. So this one can be called u. This is a v. This is what w. So in that case now, the y dx will be equal to 6x squared sine x, then d dx of cos x, okay, then plus the one you are differentiating here, keep it constant, and then you differentiate the 2 you are keeping constant in the first instance, and that will be equal to 6x squared sine x, okay, ddx of that. So then derivative of cos is minus sine times this one, and that will be minus 6x squared sine squared x, then plus, yeah, plus this is a product rule, so we're going to break it down. So it's going to be cos x, open your brackets, keep this first one constant, differentiate the second one, which is sine x, then plus the one you are differentiating here, keep it constant, and differentiate the one you kept constant here, 6x squared. Close the bracket. Then let's open the bracket and differentiate what we have inside there. So that will be minus 6x squared sine square x. Derivative of sine is cos. So cos times cos. So that will give us plus 6x squared cos squared x times this one. And then plus derivative of this one is 12x. Okay, derivative of 6x squared, that's 12x. Okay, so sine times cos, that's 12x sine x cos x. Okay, so what we can do is to combine these two together. Look at these two. Something is common there. 6x squared is common there. So 6x squared, you can take it out. You can factorize it. So, and divide the positive first, plus here. The positive, write that one first. And that will be what? Cos squared x. Then followed by what? The minus here, minus sine squared x. Okay, then plus. Check this one properly. You can see sine s cos x. Okay, so we can bring out something out there, which is sine 2x. So that will be 6x into brackets 2 sine x. 2 sine x cos x. Okay, actually at this point we are done with the solution. We're done with the solution. What we want to do is just to use a trig identity And what we want to do is to use the trig identity so that we can fetch more mark. Okay, and that's what we are doing. Okay, yeah, so this will be now become cos square x minus sin square x. That's what 6x squared cos 2x. And this one also will be equal to what? Plus 6x sine 2x. So that's what we have done. We have succeeded to turn everything to what? To double angle. And that's that on this question. So if we have a problem with a trigger identity, you can play the previous video on all those identities. Okay. And actually, you can stop here. Probably may lose like 1 mark. You can stop at this point here. Okay. So at this point here. Okay. But if you go further, it fetch you additional marks. So that's that on that. Okay, that's that on that.